All right, so we're still doing this traveling salesperson problem. And here, we're trying to find a Hamilton circuit in a complete weighted graph for which the sum of the weights of the edges is a minimum. That's the key. We're looking for a minimum. And such a Hamilton circuit is called the optimal Hamilton circuit or the optimal solution. And we're going to look at the brute force method of solving this traveling salesperson problem. And the optimal solution is found using the following steps. First, we're going to model the problem with a complete weighted graph. So that's first step. Okay, that's easy. Sometimes they give it to us, sometimes we just have to draw it. Then we're going to make a list of all possible Hamilton circuits. Okay, well, we can do that. Then we're going to determine the sum of the weights of the edges for each of the Hamilton circuits. Okay, well, we can do that just like we did kind of in the previous short video. And then the Hamilton circuit with the minimum sum is going to be our optimal solution. All right, so that's kind of what we have to do. So let's look here. It says use the brute force method to find the optimal solution for the complete weighted graph here. Now, what we want to do is list all the Hamilton circuits in a table format. So I'm going to say, well, let's start A, because remember, we always have to start with the same one. So we're going to start with A. And basically, we want to start with A, end with A, and go through all the points exactly one time here. So let's maybe do A, B, C, D, A. So we're going to do A, B, C, D, A. Okay, so that gives us that one. Now we could also do A, B, and instead of going to C next, we could go D, and then C, and then A. So that would be our ones with the A and B first. Now, instead of going B first, we could do A, C. And so with that, we could go A, C, B, D, A, A, C, B, D, A. Or we could go A, C, and instead of going to B, we could go D, and then B, then A. So that's the two possibilities with going to C next. And then we know that the next possible is going to D. And so we could go A, D. Well, let's go B, C, A. Or we could go C, B, A. We could go the other way. Okay. So those are our six possibilities. So now what we need to do is we need to write down our weights. So if we go A to B, that's going to be a 20 plus, and then we have the next one's going to be 15. And then C to D is going to be 50. And then up to the top will give us 30. Okay. And we'll add these here in a little bit. So A to B again is going to be 20. And then the B to D is going to be 10. And then we'll go to 50. And then we'll go 70 this time because C to A is 70. So it's a little bigger. Now A to C. Well, A to C is 70. So it starts off bigger to start with. So we can do, we know both of those. And so now we're going to go C to B. So that's going to be 15. And then we're going to go to that. It's going to be 10. And then after that, we're going to go up and that's going to be 30. And now instead, if we go C to D, that'll be a 50. And then if we go to B, that'll be a 10. And then that'll be a 20. And then A to D, that's going to be a 30 for the first two. And then if we go to B next, that's going to be a 10. And then if we go C, that's going to be 15. And then we'll go 70. And then 30. And now if we're going to C, that's going to be a 50. And then if we go over to 15 is for the B. And then up is going to give us 20. All right. So now if we type all those into our calculator, what we're going to get is we're going to get 115. That's going to be 150. That's going to be 125. That's going to be 150. That's going to be 125 again, and that looks to be 115. So if we want the optimal solution, what does that mean? That's the minimum. Well, guess what? We have 115 here, and we have 115 here. So there's two optimal solutions. So this is going to be one, and this is going to be our second. So we're going to have two possible optimal solutions. And so that's just how we do it list it. We'd show both of those as optimal solution, and they wanted us to show the completed table here. So we've got a table of all our possible, roots. We have all the weighted totals, and then we found our optimal solution being the smallest of the values here. Okay, so that's how we're going to do brute force. Now we'll stop there, and then we'll come back with the nearest neighbor method.